Hello, math students. Today we're going to be going over some basic geometric concepts. I suggest that you follow along very closely, and you might have to rewatch a couple things here. This is going to be an important lesson for you to understand the next few units. So for this lesson, just try your best to understand each of the definitions that we're talking about, each of the concepts, and just follow along, do everything I do, and write down everything I tell you to write. And write down everything I write, and you'll do well, I promise. So let's go ahead and get started. I'm on page 5 of the tutorial, and a couple things we want to cover first is what's called a line segment. So see, we have a couple of line segments here. We have line segment AB, and we have line segment CD. It's like a line in that it's straight, but it's a line segment. And the main difference between a line and a line segment is that lines go on forever in both directions. So if you see, for example, these are both line segments, but if you were to see like an arrowhead on each end like this means that it's a line. That means it goes on forever in both directions. But these ones don't have that. They have endpoints, right? So since it has 2 endpoints, these are actually not lines, they're line segments. And we write line segments, notice, with the 2 endpoints. AB is the name of this line segment, and we put a little segment on top. Same with CD, and we put a little segment on top. Line segments, we usually just call them segments. So, and then the other thing is angles. So here we have an angle. It's angle ABC. You could also call it angle CBA, or in this case, you could just call it angle B. So angles, you can name them in multiple ways, and sometimes it's necessary to name them with the 3 letters, A, B, C. And notice we put a little angle in front to say that we're talking about an angle. And when we talk about the measure of an angle, it's a measurement of how open the angle is. So if right here, this is maybe a 10-degree angle or something, and then as I open up, that angle measure increases. So the angle measure is how open that angle is. Now, point B in this case is what we call the vertex of the angle. So that's one important concept, is that the vertex of the angle is where the measurement of the angle is, essentially. Okay. So we're going to get started right away with an activity on page 6. In this activity, you will use GeoGebra geometry tool to explore the properties of line segments and angles. Open GeoGebra and then complete each step below. If you need help, follow these instructions for using GeoGebra. So let's go ahead and click on this GeoGebra link, and it'll take you here. You have to know this this piece of software, okay? This piece of software is going to be part of not just this lesson, but in many lessons to come throughout the rest of this geometry. So you really need to know and be able to work with this software. So open it up and we'll go ahead and get started. Okay, plot 3 points on the coordinate plane, label them A, B, C. Be sure that the 3 points do not lie on a straight line. Now join the points 2 at a time using straight paths. How many unique straight paths can you make through the points? Which geometric figure is formed? So you can put the points anywhere you want. So how do I make a point? If you look up here at the various tools I have in GeoGebra, this first one here is called point, and you can just click, click, click. Any 3 points are fine. It should automatically label them A, B, C. Now what you want to do, and make sure your points are not all in a straight line, okay? Now what we want to do is it says connect the points in as many ways as we can. So we're going to go over here. Don't go to line. We're actually going to go to segment, click on segment, and then connect the segments, creating the segments. So we have segment AB, we have segment AC, and then we have segment BC, okay? So what figure is formed? Well, hopefully you recognize that that is a triangle, okay? So what you want to state here is we were able to make 3 straight paths, which formed a triangle, okay? So a triangle is made up of 3 segments, essentially. 3 connecting segments makes a triangle. All right, the three paths intersects in pairs at points A, B, and C. Measure and record the angle formed at each intersection. Also measure and record the lengths of the straight paths or sides. Capture the image and paste it or insert it below. So now let's go back to that GeoGebra that we created, this triangle. Now we want to find the angle measures here. Okay, so how do we do that? So in GeoGebra, go to these tools, and if you go to this here, go to angle. Okay, this will allow you to find the measure of angles. So if I want to find the measure of angle A here, this interior angle, what you actually need to click is B, then A, then C, and it'll automatically tell you what the measure of that angle is. In this case, in mine, it's 70.05, but yours will probably be different. Okay. Then if I want to find the measure of angle C, I click A, C, B. Okay, here it shows 65.6. And then if I want to find the measure of angle B, I click C, then B, then A. Okay. Now, if I notice there, you might notice over here for the angle C, it's kind of like on top of, the labeling is on top of itself. If you want to move stuff around, you have to go back to the arrow tool, go to move, and then you can move stuff around. Okay, so you can move things so it's easier to read. All right. Okay. Now, one thing you could also do, since I'm still on the move tool, I can move the points around and it'll automatically change what the measures of the angles are, okay, according to what they are, okay? Remember, the more open an angle is, the bigger its measure, right? So if I make angle A, notice I'm making it more open here. Now its angle measure is much higher, right? Whereas B and C are more closed in this triangle, okay? Here, the angles are smaller. Angle A is smaller than what it was, right? It's more closed. So you can move the points around and see how that changes the angles there. Now it also asks for the distance of each segment. So the length from A to B, right? And B to C and A to C. So let's go back to this angle here, but you're actually going to go down to distance or length. So distance or length. Then if I want to find the length of AB, I click A, B. And it should say AB equals 9.25. That's what it is for mine. Yours will probably be different. Click A, C, click B, C, and you should see the different lengths there. Okay, so it tells you the length of each of the segments. Okay, then it asks you to take a screenshot and save it and post it. So I'm just going to use my snipping tool here, grab that, copy, paste. It's not letting me paste, but you can save the image and then insert the image like this, okay? Okay, here I pasted it there. There you go. So yeah, you can click on this and paste the image in here as well. You can also drag the file. You could save the file and drag it in as well, okay? So just like that. So we can see all the information here that I have, okay? Question 3. The three straight paths, segment AB, segment BC, segment AC, each meet each other at 3 points, A, B, and C. How do these points of intersection differ from each other? Explain the differences in terms of the angles that you see. Also, look at the lengths of the side opposite of each angle. What pattern do you see regarding the measurements? In what situation would all the points intersection resemble one another? Modify the triangle in GeoGebra to help you answer the question. Okay, so this is a lot that they're asking here, but basically what they want you to see is this. So let's go back to GeoGebra, and I'm actually going to change the measures of the angles a bit. So I'm going to make angle A quite a bit larger here. So I'm going to make it over 100 degrees. Notice points, when I make it bigger, the angles for B and C got smaller, right? Okay. I want you to also look at the lengths of the segments. So notice from angle A, this is obviously the largest angle measure, but which side length is the largest? Well, it's BC, isn't it? So notice opposite from if I look at the largest angle measure, the largest side is opposite from it, right? So this is the largest angle measure. And if I look opposite from it, I would see the largest side length. Which of these angles has the lowest angle measure? Well, that would be angle B in my triangle, right? Angle B has the lowest angle measure. And which side length is the lowest? Well, it's the side length that's not touching it, right? Not touching angle B. Notice this is the smallest side length. And then the medium angle opposite from it is the medium side length. So medium length side length. So the thing that they really want you to see here is that when you have a triangle, the angle with the largest angle measure will have the longest side opposite from it, as well as the smallest angle measure will have the smallest side opposite from it. Okay, so that's what they want you to explain here. That within a triangle, the largest angle measure will have the longest segment or side opposite from it. Okay. Similarly, excuse me if I spell things wrong, I'm not the best speller. Similarly, the smallest angle measure will have the shortest side opposite from it. So make sure to say that as well. Okay. Use GeoGebra to move points A, B, and C to the locations shown in the ordered pairs in the table. Record the lengths of each side and measure of each angle resulting in the triangle. Note that the length of a line segment is denoted by 2 letters but no bar on top. Example, AB reads as the length of segment AB. All right, so here we want to find the length of the segments and the measures of the angles. Okay, so there's a couple things I want you to keep in mind here when we're doing this. Let's go and move the points to these locations. So 3, 4, 1, 1, 5, 1. Okay, so A is at 3, 4. So I'm going to move it now, 3, 4. B is going to be at 1, 1, and then C will be at 5, 1. So B will be at 1, 1, and C will be at 5, 1. Okay, so you should see this triangle right here. Okay, if the labels are kind of overlapping, you may need to move them so it's easier to read. Okay, then you just want to record the information into the chart. Okay, so first the length of AB and AC, they're both 3.61. So right here where it says AB, 3.61, as well as, what was the other one? AB and AC are both 3.61. And what was the length of BC? It was 4. Okay, so those are the 3 lengths. Now, what are the measures of the angles? So notice it says, this first one says measure of angle ABC. So the vertex of that angle that it's talking about is actually B, okay? So when it says the measure of angle ABC, they're actually talking about, so the angle ABC is actually this angle right here. So this is angle ABC. Notice that you could think of it as A to B to C. That forms this angle. So angle ABC is going to be 56.31. BAC, notice A is the vertex in this case. BAC is going to be 67.38. And then ACB is the same as ABC, right? Where C is the vertex, 56.31 degrees. Now we're going to move the vertices according to this. So A is going to be at 4, 5. A, we're going to move to 4, 5. B is 2, 1, 2, 1, and then C is going to be at 7, 3. Okay, so then now we have this new triangle. So I want you to go ahead and record the side lengths and angle measures that you see right here. Okay. Record the, so you may need to pause the video, record the angles and side lengths and angles that you see from that picture. Then we're going to move the vertices according to these points right here. So 3, 6, 3, -2, and then -3, -2. So 3, 6, 3, -2, 3, -2 is down here, and then -3, -2, -3, -2. Okay. Now you may notice that our angles are a little bit weird for this one. So notice all the angles, they're now looking at like the exterior angles. So you may need to, we're going to have to fix that. And the way we're going to do that is we're going to remove the angles. We're going to get rid of these. Okay, we don't want to see those anymore. And we're going to have to refine the angle measures. So go back to distance or length right here, go to angle, click CAB to get angle A, B, C to get angle B, which is 90 degrees in this case, then B, C, A to get the measure of angle C. You may need to move these things around so you can clearly see. Okay, just like that. Okay, so then record the side lengths and angles that you see here. If you move point C towards point B along segment BC, how does the measure of angle ABC change? How does the measure of angle BAC and measure of angle ACB change? What happens to these angles if you move point C away from point B along BC? Okay, so this is a lot. Okay. So if we move point C toward point B, we're going to see what happens to our angles. So we're going to move point C towards point B. Okay. What I want you to notice here is that this angle, angle C, is getting larger, right? Larger measure. Point angle B is remaining the same, and then angle A is getting smaller. Okay. So when we move point C towards point B along AB, or sorry, BC, here you might want to, I'm just gonna, oh, that's not gonna help me. We could do equation editor. I want to do angle. Okay. So the measure of angle ABC, so that's really angle B, remains the same. Remains the same. The measure of angle BAC, so that's really angle A, gets smaller. And measure of angle ACB gets larger. Okay, so that was when we were moving point C towards point B. Okay. Now what happens if we move point C away from point B? So we're moving point C away from point B. Notice angle B remains the same. Angle C gets smaller and smaller. And angle A up here, gets larger and larger, right? So I want you to state those things, state those concepts in the next sentence, okay? When we move point C away from point B along BC, the measure of angle ABC remains the same. So angle B remains the same. BAC gets larger, and then ACB gets smaller. Question 6. You may need to pause and write that out. Question 6. Delete segment AC and focus on the intersection of AB and BC, keeping points B and C fixed. Okay, so we're going to delete AC. So let's go ahead and click on AC here. If you right click, you can delete it. We're actually going to delete that too. Okay, so we deleted it. Keeping points B and C fixed, move point A to a different location and observe how angle ABC changes. So we're going to move point A around, and I want you to see how angle B changes here. So angle ABC, or in other words, angle B. If I move A around, so if I move A towards C, this angle gets smaller, right? Which makes sense because it's like closing, right? Remember the measure angle, the angle's measure is how open it is. So if I move A and C closer together, you can see the measure of angle B is getting smaller and smaller and smaller, right? It's closing. However, if I move A away from C, the angle measure gets larger and larger, right? Okay. What happens if we move? So what must you do to increase or decrease the measure of the angle? Well, if I move A towards C, or more, move A and C closer together, then that makes the angle smaller. If I move A and C farther apart, then it makes the angle larger. So go ahead and explain that there. Then what happens if you move point A to a location directly on CB? So if I move point A directly on CB, well, then there's no angle there, right? So that it got completely closed. So what is the measure of angle ABC at this location? In that case, it's the angle is 0. Okay, so when it completely closes, basically the measure of that angle is 0. Okay, so I want you to explain that. Once you're done explaining that, let's go ahead and move along. And you can meet me here on page 9. If point D is placed on AC, how will the measure of angle DAB relate to the measure of CAB? Okay, so I'm creating another point D, and I'm putting it on AC. So I'm creating another point D, essentially. And I want to say, how will the measure of DAB, so where's DAB? So DAB is this angle right here, okay? So essentially angle A, right? How does that relate to the measure of angle CAB? So angle CAB, what's that? CAB, well, that forms the same angle, doesn't it, right? So in this case, the measure of angle DAB and CAB, they're actually the same angle, right? So they will be equal. Now we're going to talk about circles. So we're going to talk about some principles about circles that we need to know. We're going to have to work in GeoGebra some more. So once again, you need to know how to use this application. This activity, you will use the GeoGebra geometry tool to explore properties of circles. Okay, so open GeoGebra, then complete each step below. So we're going to open a new GeoGebra page. It says plot point A at 5, 5. Use the line tool to create AB with a length of 4 units from point A. So how do we do that? So first we need to create a point at 5, 5. This will be point A. Oop, I don't want to do that. By the way, there's always an undo. I didn't mean to create that second point, so I'm just going to undo there. If I need to move this image around, you can click and drag, but you have to click on the arrow tool first. Then you can click and drag this around. Okay, so now what we're going to do is go to here. We're going to go to segment with given length. In this case, we wanted a length of 4. So segment with given length. Then it says select the point and then enter length. So we're going to select the point A, and then the length we want is 4. Enter. So what we've created is a segment with a length of 4. Now go back to the arrow tool, and what I can do is move point B around. Notice it'll stay 4 units away from A. Okay, so we can see no matter where I move B around to, the way we did it makes it so that no matter how we move B, this stays 4 units away. Okay. Move B around point A, keeping the length of AB fixed. So the length is fixed, 4. Capture the image and paste or insert in space below. Okay, so one thing it says turn on the trace feature. So let's go ahead and we're going to right click on B. Then you want to go down to show trace. So show trace. Now, when I move B around, what image is formed? Okay, so you can see it forms a circle, right? So it forms a circle with a radius of 4. So the radius of this circle is whatever the length from the center of the circle to the edge of the circle. Okay, so then you would take a screenshot of that and put it in there. Okay. Create a circle such that the center is point A and B is a point on the circle. Capture the image and paste or insert it in the space below. How does the shape you trace in the part of the activity compare with the circle you created in question 1? So what you would do here is go to this circle tool, and then we would go to circle with center through point. Okay, so you click on this, click A as the center, and then click B as the point, and it will create a circle right over your trace, just like that. Okay. So we would say that the circle we just created is the same as the traced circle that we found in question 1. Make sure to take a screenshot of this image and put it right here. In question 1 and 2, what is the distance from the center of the circle to the point on the circle? Well, hopefully you know that that's 4, right? Because that's the distance between A and B. Take this idea a step further. What is the relationship between the center of the circle and the points that lie on the circle? So the main thing they want you to see here is that not only is the distance between A and B 4, but it doesn't matter. I can move B anywhere and that same distance will be 4. So the distance from A to, so the center of the circle, to the circle itself, that distance will be 4 all the way around. So whatever the distance from the center to any point on the circle, that same distance will be the same all around. So in other words, the radius is the same all the way around from the center to the circle itself. That's what makes it a circle, is that that distance remains the same. Okay, so you just need to explain that there, that the distance from A to B is the same as the distance from the center point A to any point along the circle. Once you've explained that, we're going to move along. Okay, so here we have a circle. It says point C, 2, 2, is the center of this circle. What is the ratio of length from AC to length of DC? So they're asking the length from AC, so A to C, and DC. Well, what do you think is longer, the distance from A to C or the distance from D to C? Well, it should be the same, right? Because once again, the distance from the center to the circle itself, that distance will be the same. So the distance from C to B is also the same, and the distance from C to E is also the same. These are all that will be the same length. So what's the ratio there? 1 to 1, meaning they're the same. Okay, let's move along. We're going to talk about perpendicular lines. So perpendicular lines are lines that cross at a 90-degree angle. So this is an important concept, and hopefully you learned some of this in algebra. And basically, yeah, perpendicular lines cross at a 90-degree angle. Just like one street that goes north and south and another street that goes east and west, they would be perpendicular routes because they cross at a 90-degree intersection. Okay. Once again, we're going to be using GeoGebra here, so make sure you understand and follow along for the GeoGebra stuff. Okay. Use GeoGebra to explore the properties of perpendicular lines, then complete each step below. Okay, so go and click on this perpendicular lines link, and it should open another GeoGebra tab, and you should see it, and it looks like this, okay? Notice that, and I might want to zoom out a little bit here. Notice that line AB is perpendicular to line CD, and it's also perpendicular to line FG. Right? Because AB is crossing those lines at a 90-degree angle. And again, that means that they're perpendicular. That's what perpendicular means. So it says move point B to a different location on the coordinate plane. What do you notice about the relationship between BG and GF? Explain in terms of angle BGF. So let's look at angle BGF. Well, that's this angle right here, this 90 degrees. So when I move point B around, okay, let's see. Well, we could see that BGF remains a 90-degree angle. Remains a 90-degree angle, meaning that AB is still perpendicular to FG, no matter where we move it. BG and GF. BG, yeah, so BG and GF are still remain perpendicular to each other because the angle of the measure of angle BGF is still 90 degrees. So that's what you want to say, is that the line BG and line GF are still perpendicular to each other because they still cross each other at a 90-degree angle. So just explain that there. Move point B some more. As you move point B, the angle formed between AB, line AB, and line CD varies. If you want to make AB perpendicular to CD, what do you need to do? Explain in terms of angle BEC. So first, angle BEC is this other angle here. Notice if I want to make them perpendicular, I need to move point B such that the measure of angle BEC is also 90 degrees. Okay, so that's what you want to state. In order to make AB and CD perpendicular, we need to make the measure of angle BEC be 90 degrees. Okay. Explain that just as I did. Describe the relationship between GF and CD when the two lines are perpendicular to AB. So I'm actually going to reload this. Notice that when these are both 90 degrees, in other words, AB is perpendicular to both GF and CD. So AB is perpendicular to both of these lines. What do we notice about lines CD and FG? What do we notice about these two lines that are going this way? Well, they're both perpendicular to AB, but also they're parallel to each other, meaning that these two lines, no matter how much we zoom out, these two lines would never touch each other. So since they're both perpendicular to AB, then they're actually parallel to each other. Okay, so we would say line CD is parallel to line FG. So line CD is parallel to line GF. Okay. So when both GF and CD are perpendicular to AB, then GF and CD are parallel to each other. Okay. And you just leave it as that. That's fine. Okay, let's go ahead and move along. Okay. Line AB is perpendicular to line CD. How many 90-degree angles are formed by the intersection? 4. Okay, so one thing to keep in mind, and I'm just going to go show you here. When two lines are perpendicular to each other, not only is there a 90-degree angle here, but there's a 90-degree angle here, a 90-degree angle here, and a 90-degree angle here. So 90-degree angles are so important and so commonly used, we actually have a special name for them. They're called right angles, right angles. So 4 right angles are formed, and we even give it special notation. A right angle gets this little square here, okay? One way to remember that is that a square itself has 4 right angles in it, doesn't it? 4 90-degree angles. Okay. So when two lines are crossing, they're perpendicular, meaning they cross at a 90-degree angle, it actually forms 4 90-degree angles at the intersection. Parallel lines. Use GeoGebra to explore the properties of parallel lines. So we're going to click on this link here. And we probably need to zoom out a bit here. Okay. Study the order pairs in the table. Move point D to the location shown. And note the measure of angle DFB and the measure of angle CEA and the length of AE and the length of BF. You can turn on the grid to find the locations more easily. Round angle measures to the nearest degree. Okay, so let's move point D to 12,2. Move my face over here. Okay, so 12,2, we're gonna move point D. So you're gonna make sure you have the arrow tool selected, and we're gonna move to 12,2. So that should be right there. You can make sure you're in the right spot because you can see 12,2 here. Then it asks us to find the measure of angle DFB. DFB is this angle right here with F as the vertex. So it said round to the nearest degree. So we would actually round it to 85 degrees. Measure of angle CEA. CEA is 95 degrees. The length of BF and AE. BF has a length of 2.72 and then 3.29. 2.72, 3.29. Okay. So just like that. Then you're going to move point D to 11, comma 1. So let's go ahead and do that. Go to D here, move to 11, comma 1. Okay, should say 11, comma 1 over here on the left. And then you want to state what the angle measures are once again. So this one says round to the nearest degree, so that'd be 81. Because the 80.5, that 5 rounds it up, right? And then this one, 99. BF has a length of 2.03. And then AE has a length of 3.04. Okay, then do the same for the next point. So 4, comma 2, move point D to 4, comma 2. Okay, should say 4, comma 2 here. And then you want to go ahead and find those same things, okay? This is kind of weird. It gave you the exterior angle. So you might want to go back to angle here, go to D, F, B. So it should say 90 here. Okay, and then put in the things here. So this one was 90. This one should also be 90 because it formed right angles. Put the lengths here, and then do for the other points as well. Based on your observations from question 1, what is the relationship between segment AE and segment BF when the angle DFB and CEA measure something other than 90? In this situation, what is the relationship between line AB and CD? Okay. So when we move point D such that these are not 90 anymore, what do we notice about AE and BF? Well, AE and BF will not be the same length. They will not be the same length. So AE and BF will be different lengths. And then DFB and CEA, notice they always add to 180 degrees. So you would say that angle DFB and angle CEA always add up to 180 degrees. And then in this situation, what is the relationship between AB and CD? So when we look at lines AB and lines CD, are these two lines parallel? Well, no, they're not, because they will cross. You can see over here, they do cross. So when it's not 90 degrees there, then the AB and CD are not parallel. What condition is necessary for AE and BF to be equal? In this situation, what is the relationship between AB and CD? What can you conclude about parallel lines with regard to the distance between them? Use the words perpendicular in your answer. So, in order for AE to equal BF, we should say that CD needs to be perpendicular to FB. Line CD must be perpendicular to, what line did I say? FB. When that happens, lines AB and CD are parallel to each other. Okay. And you can see that here, that when I make this such that it's perpendicular, such that these are all 90, notice that AB and CD are actually parallel to each other now, right? And the distance here between FB and EA, they're the same length. Okay. What can conclude about parallel lines with regards to the distance between them? The distance between parallel lines remains the same throughout. Okay. And you can see that here. The distance between them here is the same as the distance between them here is the same as the distance between them all the way along, right? Okay, hope that made sense. Okay, if you follow it along and you're able to get through it, then that's great. Line AB is parallel to line CD. AC and BD are perpendicular to line AB and line CD. What is the relationship between AC and BD? They must be equal to each other. Okay, that's kind of what we were talking about in the last lesson, that when these two lines are parallel, that the distance between them, AE and BF, they remain the same. They're equal to each other, that distance between them. Okay. All right, let's go ahead and get started with the mastery test for this. You're going to be offered 5 questions. I have 10 questions here, but you're only going to have 5 of these. But if you follow along and with all 10 questions, you'll get a fuller understanding. So if you can do that, that would be great. And on top of that, if you're not subscribed yet, especially for you returning viewers, I would definitely suggest doing that. It's just a way to say thank you for putting all the hard work that I do into this. Anyway, let's go ahead and get started. So I'm going to give you at least a hint for each question. I may not give you the full answer, but I'll give you a hint at least for each question. If AB is parallel to CD, which statement is true? So one thing you need to know is what parallel means. Parallel means the two lines, they won't cross each other. Okay, so they look kind of like this. And this is definitely a definition that you should know by heart. Okay, parallel means that the lines don't touch. One way to help you remember that is that parallel, notice it has 2 parallel lines in the word itself. Okay, in the L's. Okay, that's just one way to think about it. Okay, number 2. In the image, point A is the center of the circle. Which 2 segments must be equal length? So if you remember, if you have a circle, the center of the circle, the distance to the circle itself is called the radius. And that same radius is the same no matter where you're looking from. Okay? So basically, which 2 segments listed here are both radii, I guess. Okay. Select the line segment. So if you remember, a line segment does not have arrowheads. So if it has an arrowhead, that means it continues going. So if it has arrowheads on both sides, we call that a line. If we have arrowhead on just one side, we call that a ray. And then if it doesn't have arrowheads on either side, then that's a segment, okay? But it needs to be straight just like a line. That's why we call it a line segment. Okay. On the road map, which street is parallel to Waterloo Street? So Waterloo Street is right here. Now, which street is parallel? That means that the 2 streets do not intersect. So which street does not intersect Waterloo? Okay, this one's a little bit tricky. If each point in the diagram can act as an endpoint, how many distinct line segments can be formed using the set of points? Okay, so let's list them out. So starting from point A, we could say AD is a line segment. AD. We could also say AC, that's a different line segment. And then AB, the whole thing, right? Okay. Then going from point D, we could say DC. That's a distinct line segment. That's different than all the other ones that we've listed so far. And then DB is another different line segment. And then the last one, starting from point C, CB, is a line segment. Okay, so 6 in this case. Now, one thing to keep in mind is, notice I said AD for this first line segment. Well, you could also call it DA. So segment AD is the same as segment DA, the same segment. So you don't have to list it twice. Okay. Which point represents the vertex of the marked angle? So we're talking about this angle here. Okay, angle AEC. Now, when you have an angle, doesn't matter what the angle is, the vertex is this point right here. Okay, so this is your vertex. So what would be the vertex of this angle here? So here we have a circle. Okay, Cynthia is standing at the center of the circular playground. So Cynthia is standing right here at the center. Which statement is true with respect to Cynthia's position? Okay, so remember, the distance from the center of a circle to any point on the circle, that distance is called the radius. Okay, and it's the same distance, that radius is the same distance from the center to any point on that circle. So this would be the same distance. This would be the same distance. This would be the same distance. Okay, so that's kind of what you need to think about when answering this question. Okay, so remember, Cynthia is right in the center. That's one thing. Okay, select the correct answer from each drop-down menu. In this figure, segment AB and segment CD are parallel. So A to B is parallel to C to D. Okay, and you can kind of see that there, that those two vertical lines, they're parallel in this case. They will not intersect. Okay, AB is perpendicular to line segment. So what does perpendicular mean? Well, remember, perpendicular means that they cross at a 90-degree angle. Okay, so when two lines or two line segments or a segment and a line or whatever, when they cross at a 90-degree angle, we call them perpendicular. Okay, so AB, that's this one here on the left, is perpendicular to what? Okay. If the length of EF is A units, then the length of GF is, so if length of EF, it says here, is A units, then what would be the length of GH? So if this is A units, what would be the length of GH? This next one's kind of tricky, especially the way they word it, but you have this picture here, and we see that there are actually kind of two angles here, but also they can think of them as forming one bigger angle. But it says the angle by which segment AB turns clockwise, so that's this, so AB is this highest one, we want to turn it clockwise, about point B to coincide with BC is blank degrees. All right, so this one's tricky. But basically, if we move this segment so that it lands onto this segment, how many degrees of movement would that be? So that would be the sum of these two angles. So what you'd do is you would add the 33.3 degrees plus the 30.6 degrees. So that would be 63.9 degrees. Okay, so that's what you would want to put here. If from point B, a point E is drawn directly opposite from point C, so that B, E, and C are on the same straight line. Okay, so let's first draw where point E should be. So it says B, C, and E are on the straight line, and that E is opposite from C. So E would be like over here. Okay, such that this forms this straight line like this. Okay, this is a straight line across. Okay, hopefully that makes sense. Okay, then it asks the angle by which segment AB turns counterclockwise. So AB was like this, turning counterclockwise, to coincide with BE is blank degrees. So it's asking, I change colors here. It's asking, what's the measure of this angle here? Okay. So how do we figure that out? Well, one thing that I haven't mentioned yet, but is an important concept in geometry, is that whenever you have a straight line, the number of degrees in a straight line is 180 degrees. Okay. This is an important concept that you definitely need to know. You need to know this basically on hand. So any straight line, if I think about the measure of its angle, that's 180 degrees. Okay, so starting here, going this all the way flat, that's 180 degrees. Okay, so if I think about the entire straight line here is 180 degrees. And this blue part is 63.9 degrees. So the way we can find the red angle is by taking 180 degrees and you subtract 63.9 degrees. And that'll give you the measure of the red angle, which is what we're looking for. So you'd put that here. Okay. So 180 degrees minus the 63.9 degrees, the blue, and that'll give you the red. You could use a calculator. Match each pair of lines with the correct description. Okay, so one of the descriptions says parallel lines. So when I look at this picture, what set of lines would be parallel here? Okay, remember, parallel lines do not cross each other. They do not intersect. So would that be EF and CD? Would that be GH and EF? Or would that be AB and CD? Okay, the next thing, so what you do, you would just drag this to over here and then drag the correct pair of segments to here. Okay. Then it says perpendicular lines. So perpendicular lines mean that they cross at a 90-degree angle. Okay, so you can see there's a 90-degree angle here, and then another 90-degree angle here. So you got a couple options. Could be CD with EF, or it could be AB with EF. And then neither parallel nor perpendicular lines. That just means two lines that cross each other, but not at a right angle. So any two lines that cross each other, but they don't cross at a right angle, could be like this. See, none of these are right angles. So these would just be neither parallel nor perpendicular, right? They're not parallel, they cross, but they're not perpendicular because they don't cross at a right angle. Okay, so figure out which set of lines would describes that, neither parallel nor perpendicular. Okay, well, that's it for the mastery test, and that's it for the lesson. Hope that all made sense. If you have any questions, leave them in the comments section. If you're not subscribed already, please subscribe. It really helps me out. And with that, take care, and I'll see you guys next time.